Hello and welcome back to part 2 of lesson 6. If you haven't done so already, please make sure that you watch part 1 of lesson 6, which is available in another video file from the same place where you downloaded this file. Okay, let's go ahead and jump back into talking about object-oriented programming. We've already covered the basics, so now we're going to get into some slightly more advanced topics. We've already looked at event handlers as special methods that are executed whenever an event is triggered. So in the case of, for example, our form here, we have already seen how we have a click event for button 2, and whenever the user clicks on that button, we can write code, and this method, private sub button 2 underscore click, will execute to react to that event. Now there's another special method that executes whenever a new instance of an object is created. So when the new keyword is used in Visual Basic, you can write code in what's called a constructor that will allow you to initialize the instance of the new object. Now, what does it mean to initialize? Well, that really depends on your particular situation. It could mean that you set the field names immediately, or I'm sorry, the field values immediately to some default values like we're going to do here in just a moment. Or perhaps it means that you'll check in a file or in a database for some information, or perhaps 100 other possible things that you could do. The use of constructors will actually become a little bit more obvious after you start creating object-oriented applications and you have a use for them for initializing values and so forth. So let's take a look now at how to define a constructor. Let's go to our car class, which we created in the previous video, and let's move below our properties but above our method and pop in our constructor. So you can see what we have is a new method, public sub new. We're setting our m underscore make, m underscore model, and m underscore elapsed mileage at the very beginning, and then we're going to display a message box. So what I'm going to do is just show you rather than explain to you how this works. I'm going to place a breakpoint here on this line of code, line number 8, where we're creating a new instance of the car object. I'm going to run the application, click my button, and then I'm going to start to step into, and notice immediately that we come to public sub new, and we're going to execute these. Currently, make, model, and elapsed mileage are set to nothing, but as we begin to execute these lines of code, we populate them with default, default, and 0 respectively. And then we're going to now pop open a message box. It just shows that we have called our constructor, and now we continue on with the rest of our application. Okay, so again, this is code that we want to execute each time a new instance of our class is created. In this case, we initialize the values, the underlying private fields that we created at the very beginning of our class car, and we could have done a number of different things here. In fact, whatever we needed to do in order to get our newly created object ready for use by the code that will actually call it and manipulate it and work with it. So that's the concept of a constructor. Now let's talk about the concept of overloading in object-oriented programming. Now I might be overloading you with too much information right now, but that's not the overloading we're going to be talking about. In object-oriented programming terms, overloading means that we create two methods with the exact same name. The only difference is what is called the method signature, or rather the number of arguments that the method accepts. So let me show you an example of this, then I'll explain why you would want to do this. So right underneath our new method, I'm going to paste in another new method, another constructor, and as you can see here in my text, I could have created an overloaded version of drive just as easily, but since we're talking about the constructor, I decided to create an overloaded constructor by creating a second method signature that now has 3 parameters. We pass in make, model, and elapsed mileage, which we then use to set and initialize the beginning state of our newly created instance, instead of setting it to values that are not pertinent to what we're trying to accomplish. Okay? Now let me show you what that does for us. Let me save this and then go back over to our Form 1 code. I'm going to go to the very bottom here. In fact, I'm going to comment some of this stuff out. And we'll remove that. And let's go ahead and comment this out as well. Okay. But now let's do this. Dim my other car as car equal to new car. And now notice whenever I start the open parenthesis, notice that I get some IntelliSense, and I can use either the up and down arrow on my keyboard or the little arrows with my mouse to look at the two method signatures for our new method. Now, why is the keyword new used? I guess I didn't really talk about this with constructors. It's just a keyword that is used in order to denote a constructor, okay? So you can see it represented here. Now, what I can pass in is all the information I used before, like Oldsmobile, Cutlass Supreme, and 200,000 as my lapsed mileage. And now I have not only a new instance of my car class, my other car, but I was able to initialize the values right away. So let's do this. Let's go back over here to car class. Let's set a breakpoint in my overloaded constructor and then run the application. Okay, so we can see the called constructor because we have already in our Form 1 code where we are creating a instance of my class. And then the second time through, we're going to now set the make, model, and elapsed mileage for my other car equal to the values that are passed in. The make is Oldsmobile, model Cutlass Supreme, elapsed mileage 200,000. Okay, pretty easy stuff, right? We're just going to run through this, and now you can see the line of code executing back in the Form 1 button to click event. So now we have my other car with elapsed mileage, make, model, all populated. Very neat. Okay, let's go ahead and stop it right there. And I'll comment this out. Okay, so that's the how you do it, but why should you ever overload a method? Well, overloading is something you do as a convenience. In this case, instead of using the default constructor to initialize the values to some default that really doesn't make sense to us, something that doesn't really useful to us for our application, instead of doing that, perhaps we want to have an option for those programmers that will use my class to specify the values that are to be used for the initialization of the properties. So I can pass these in as parameters and have them set at the point that the object is first created in memory. So when you think of overloading methods, any type of method, whether it's just a method like the drive method, or if you are overloading a constructor like we did just now, think of the convenience of having multiple ways to call the method from the part of code that consumes your object. Just convenience, just two different ways to do the exact same thing, depending on what information you have available to you while you're trying to make this call, or whatever your purposes are. You might want to allow several different ways, several different method signatures, as long as you can accomplish ultimately the same thing. Okay, so that's the concept of overloading. Now, let's move on, but before we get too far, I just want to make a couple of observations. In the previous 5 lessons, we pretty much coded everything as a result of the button 1 click event, and that was fine. We didn't have to really think too hard about where to place the code for at least the first 5 lessons, but it really limited how complex our applications could be. But now notice that methods, event handlers, constructors, and properties all contain, or rather define, code blocks. And a class is the container for these items. You can't just have a method or a property floating outside of a class. There's a certain hierarchy. All of these structures, methods, properties, and so on only make sense whenever they're defined within the context of a class. Okay. Additionally, a class can reference another class. We've been doing this all along. As long as it somehow obtains a reference to another class, it can create a new instance of a class or receive a reference to an existing object through a property or method parameter. Okay, so as you see in our examples, our button one click event handler, which is simply a method inside of our form one class, right? It creates a reference to the car class. In fact, we've done it twice now. Our car class, in turn, could create a reference to other classes in our application. And we're going to actually demonstrate that in just a few moments. Also, before we move on, I want to talk about one little gotcha. And this might be a little complex, so make sure you're listening right now. Now, did you ever wonder why we never had to create an instance of the MessageBox class before using the show method of the MessageBox object all over the place? Now, the reason is because the show method has been defined with the keyword shared, which means that it's not necessary to create an instance of the class before using that particular method. Now, the same is true whenever we use integer.parse in the previous lessons. We never created an instance of integer. It was just a type, right? But we were able to use a method of that called parse. When you define a method with the shared keyword, it becomes different from a method that requires an instance to be used. So, for example, we could change our car class to have one shared method, and we wouldn't need to use the new keyword. We could just use car dot whatever our new method name is, as long as it's defined as shared. But the problem is that in that particular case, it wouldn't make sense for the way that we're using that car class. We may need to create more than one instance of the class to define more than one car. We might want to create and define a new class called utility that has a method that will help us calculate gas prices, for example. Now, in that case, it makes more sense to create it as a shared class since it's more of a utility class than a domain class. And don't get too confused about that. I'm going to demonstrate how to do that right now, though, so you get some idea of what we're talking about. So I'm going to click Add New Item, make sure class is selected, and then we're going to create a new class called Utility. Click the Add button so we have a whole new file here, public class utility. And inside of this class, we're going to create a function called calculate gas prices. We'll pass in the miles as an integer and return a double, which would be a dollar amount, okay? And notice that I've used the shared keyword. And we could do some other things with this calculate gas prices. I'm doing something very straightforward. I'm just taking the miles, I'm going to multiply them by 35 cents, okay? And we'll return that value back. Now, that's not really the most important part of this. Let's go to the code and try to consume this by doing this. Dim trip cost as double. Whoops, I'm sorry. Let's try that again. Here we go. Dim trip cost as double equal to utility dot calculate gas prices, and I'll just pass in 500, so 500 miles. And then we'll do this, messagebox dot show trip cost dot toString. And now let's see what happens. And let me comment out some of this stuff here. We'll come back to that later. Okay, so we get the value 175, so 500 times 0.35 equals 175. But did you notice that in the case of utility, I didn't have to create a new instance of this class. By using the shared keyword, I was able to call this calculate gas prices method without having to create an instance of the class. So that's how you create a shared method, which is also sometimes called a static method in other programming languages. Okay, so if that didn't make a whole lot of sense, don't worry. Just keep the distinction in the back of your mind that there's a difference between methods that don't require an instance of a class to be created versus methods that are shared and don't require a specific instance of the class to be created. Let's now talk about the words public and private that keep popping up in our examples. Public and private are types of modifiers, and a modifier, or rather visibility modifier as it's sometimes known, changes the visibility of that particular code block. Now in the context of a class, it refers to something we haven't talked about yet in terms of code libraries, so let's just save that discussion for some other time. Let's focus on the use of modifiers in terms of a class's properties, fields, and methods. let's look at our car class again. When we design a class, we'll want certain things to be visible and certain things to be hidden to the code that uses an instance of that class. Those things that are marked with the keyword private will be things that are not accessible by the code that creates an instance of our object. In the case of a field, for example, the only way that the code can retrieve and use the value that we're storing in our private fields at the very top of our class here is through using its associated property, as you see defined here, which we've marked with the public visibility modifier. Now let's do this. Let's have some fun here and let's change the field from private to public, then go back over here to our code and let's take all this and uncomment it out. And we'll get rid of that too, okay? So now when I go my car dot, notice that I have another little icon. It's a blue icon, which denotes a field. And it's now visible to IntelliSense because it's visible to the button 2 click event. Okay, so let's do this. Make equals Toyota. Okay, and then let's go back to our car and change this back from public to private. And then go back to our form. And notice now that we get a blue squiggly line. It says it's not accessible in this context because it is private. So we've just modified and played around with the visibility of our field and made it from private to public and then back to private and saw what kind of impact it had on the code that consumes our class. Okay, so let me tie all this together for you and let's start at the top. Notice that I'm using private for the fields, public for the properties. That's because I want my properties to be visible by the code that's created an instance of my class. In other words, I want my button 2 click event, where I created an instance of my car class, I want it to be able to set and retrieve the properties I've defined. It wouldn't make any sense to mark all my properties as private. That would kind of defeat the purpose. It would be unusable. So you might be wondering, why is there a separation between the storage of a given value in a field with the process of storing the value in the property? In other words, why separate fields from properties? Why not just make your fields public? Now, if you were wondering this, you're on the right track. Great job. The reason for the separation is because there's a concept in object-oriented programming called encapsulation. Think about a remote control for your television for a moment. When you want to change a channel, you can use the channel up or channel down button, and that will magically move to the next channel. Okay? You really don't want to know how it works. You don't need to really see the underlying circuitry that determines the current channel, and then it sends the signal to the television to change the channel and so forth. You just want a friendly user interface, a single button, and let the complexity be hidden beneath the remote control's plastic exterior. Okay, when you're creating classes, you'll want to keep the complexity of how the class works hidden from the code that wants to create and use an instance of that class in order to accomplish something in an application. So there are some things that you want to keep private and some things that you want to make public. To extend our analogy, you want to provide just a couple of friendly channel up and channel down buttons and prevent the consumer of your class, the user, the programmer, from having to worry about how it works. This is sometimes referred to as black box programming. And the thought is that a class should be considered as a black box that just works. You don't have to see the underlying code to understand what it does. Just look at its methods, send the information in that it needs, and it'll spit back to you what you need to get back. You don't need to see how it works internally. Now there are some practical reasons for this. Perhaps you want to filter out values for your properties that are just ridiculous and would potentially crash the application. So you don't want somebody to set elapsed mileage to like 2 billion, for example. Or perhaps there's other dependencies between the properties that you have. And by allowing the properties to be set in the wrong order, it would create a problem. Whatever the case might be, as you're starting out, these might not seem like good reasons to go all the extra work to create properties and fields, but I assure you that the principle of encapsulation is very important. So let's extend our example so that you can see how we can modify the make property, for example, that we have here, only to accept certain values that our application can understand and reject those that we will not be able to use within our application. So to put another way, we only want to allow the user to set the make property to either Oldsmobile or Chevrolet. If they try to set it to Toyota, we're not going to allow it. We're going to ignore that. So what I'm going to do is highlight my current make property, select the comment out the selected lines button, and then I'm going to paste in my new make property. Now notice that my get statement is exactly the same as before. I'm still returning the underlying m_make private field. However, the set statement has been changed to filter out any values except for Oldsmobile or Chevrolet. So let's see how this works. If the value equals Oldsmobile or the value equals Chevrolet, then allow the assignment to happen, where we're setting the m_make variable, our private field, equal to the value that's passed in through the set statement. Otherwise, we're going to set that equal to an empty string. Okay, so let's test this out by going over to Form 1, and let's go here and go mycar.make equals Toyota. Okay, and then I'm going to set a breakpoint here and a breakpoint here so that we can watch the assignment happen in both cases. Let's run our application, click our OK button, and we hit our first breakpoint. So I'm going to use the step into button. And you can see we're here at our set statement that we just looked at a moment ago. Since value equals Oldsmobile, we should allow the assignment to take place. All right, so let's continue on now, and I'm going to hit the run button until we hit our next breakpoint, and then click the step into button one more time. This time we're going to evaluate value, and we know that's Toyota, so it shouldn't allow the assignment to take place. Now, obviously, this is a kind of a nonsensical example. We probably wouldn't want to do exactly this sort of thing. However, hopefully you understand that now you have full control over whether you allow your properties to be assigned just any value that the user of our class comes up with, or whether we filter out bad values that don't have any pertinence within our application. So that's a pretty thorough explanation of the how and the why behind adjusting the visibility of your fields and properties. Also, methods can be marked with a visibility modifier. When methods are public, as we see here in our drive method that we built in the previous video in this lesson, these methods are callable from any code that has a reference to our class. So in this case, take a look at Form 1. We've already called the drive method in line 31. Okay, we were able to do that because it was marked as public. But when methods are marked as private, they're usually considered what are called helper methods, or rather methods that perform some small part of the overall function of the public methods in your class. You can think of these as the underlying functionality. The little methods that do all the dirty work behind the scenes and never get any credit for it. Okay, these are not visible by the code that has a reference to the mycar. So if we were to create another method that helped out the drive method, it would not be visible from here, just as the private fields are not visible from our Form 1 code. So private methods can be used to break down the function of one big method into smaller bite-sized methods. This makes them more maintainable and more understandable. Some people have suggested that no method should be more than a dozen or 24 lines of code for this very reason. So a best practice is to keep your methods very small, and if you have a method that needs to do several things, a public method, break it down into smaller private methods that work behind the scenes. Now, when you're first starting out, don't worry about this too much. Over time, you're going to start seeing ways to optimize your code, but nobody would expect you at this point to remember everything that I've just said. Keep in mind that what we talked about in the previous video, that there's no one correct way to write code. Some ways might be more comfortable, some ways are more expedient, some are more elegant, but there's no single correct way to write code. And hopefully, through the use of some of these examples, this is starting to make some sense. If it's not, just keep watching and perhaps watch this video a second time. Give it a few days to sink in, then try some of the examples on your own. You know, when I was first getting started, this was pretty intimidating stuff, but the more that I worked with it, the more that it started making sense for me. So don't feel bad that if you're feeling overwhelmed right now. Object-oriented programming challenges everybody at first, but eventually you'll get it, and it'll be second nature to you. We said just a moment ago that encapsulation is one of the major tenets of object-oriented programming, and now we're going to talk about another tenet called inheritance. The idea is that when you're creating classes, like our car class for example, you may run into situations where you need a more specialized version of the class. Let's say, for example, a minivan class. Now, a minivan is a lot like a car. Many of the properties of a car can also be used to define a minivan, and there's probably a few extra properties that could be added to the minivan to make it uniquely a minivan, okay? And for example, the drive method, it still applies to both the car class and the new minivan class, but the way that the drive method is implemented, in other words, the code inside of the method's code block, should be slightly different. So we could just create a new class, then copy and paste all the code from the car class into our new minivan class. However, if we did that, if we took that approach, if we ever needed to fix a problem in the code in the car class, we'd also need to fix it in the minivan class too. Now that's not a huge problem until we start adding the truck class, the sports car class, and so on. A bunch of specialized classes that are all created based on the original car class. So is there a better way? Well, yes there is. In object-oriented programming, we can just inherit from the car class. When we inherit from the car class, we'll call the car class the base class since it's the parent to the other more specialized versions of the car class, the child classes like minivan, truck, sports car, etc. These are also referred to as derived classes. Now, what happens whenever you inherit from the car class is that you get all of the existing functionality of the car class, so you don't have to write any more code, but you can extend the car class by adding those properties and those methods that are specific to a minivan or a truck or sports car or whatever the case might be. Okay, so let's do this. Let's go ahead and create a minivan class. Now what I could do is go over here and select Add Item and create a new file that will contain my class, and I could rename this minivan. That's one approach, putting each class in its own individual file. Or I'm going to go ahead and cancel this. I could just use my existing file and place more than one class inside of that file. Okay, so that might be a new concept, a difficult concept to understand, but the files and the definitions of the classes are not really coupled together. They're not tied together. Okay, so one file can support multiple classes. So what we're going to do in here is define a new class. We're going to type in public class minivan. All right, so we have our little class here. Now what we need to do is something special. We're going to go right below the public class minivan definition, and we're going to designate that we want this to inherit from the car class. So we'll type in inherits car. Okay, at this point now, the minivan class is exactly the same as the car class. And let me prove that to you by going over here to Form 1. I'm going to go to the very bottom, and I'm going to do dim my minivan equals, oh, I'm sorry, as minivan. Whoops, here we'll do this, as new minivan. Okay, there we go. There's a number of different ways we could go about that. Now I just want to show you I didn't write any code in the minivan class, right? But watch what happens. Whenever I hit the dot notation, I get the drive method, I get the elapsed miles property, the make property, and the model property. So it has inherited all of the functionality of the car. Pretty neat. And any changes we make to the car class will be reflected in the new minivan class. Now obviously it's not really that helpful to have a definition for a class that has nothing in it and just inherits all its functionality from another class. So what we want to do is specialize this class, add some new features to it, some new properties and new methods that make it unique. Okay? So let's do this. First of all, let's create a constructor for this class so we can change up how the constructor works. Okay, so instead of the default functionality for my constructor, I am going to create a new set of functionality for it. Now notice here that I get a little bit of a blue squiggly line whenever I'm trying to reference my private fields. It says that m_make is not accessible in this context because it is private. Okay, so what we need to do to the car class in order to enable derived classes to access the underlying private fields is to change the visibility modifier from private, and I don't want to change it to public because that'll give it too much visibility, but there's a nice middle ground called protected. Okay? So we're going to change this, which means that derived classes can use these private fields, but if you don't derive from the car class, you cannot see these fields. Okay, so it opens up the visibility just enough for the minivan class to be able to see our m_make member variable, our private field. So now let's do this. Let's go back. Let's save everything. Go back here, and whenever we call the new, let's see what happens. I'm going to comment out some stuff here so we don't keep tripping up on it. In fact, I'll comment out everything except for the 2 new lines of code that we've written. I'll go ahead and hit run. Okay. And now let's start stepping into this. Notice that we hit our new constructor for our minivan. But then immediately we jump up to the constructor of the car. And we start assigning these values here. Notice that we get the called constructor message box. And then we jump back to the constructor of the minivan, where we assign make the value of NA, not applicable. Okay, so whenever you are going to overload the constructor for a derived class, please note that the constructor for the base class will be called first, and all the code therein will be executed, and then the code that specializes your new class, your new constructor, will execute secondly. Okay, because that'll affect the way that your applications perform. Okay, so then we can continue on, and let's just stop right there for now, and continue building our car class. I mean, I'm sorry, our minivan class. Okay, so let's continue on, and now what I also want to do is create a new private field, m_passengers as integer. Okay, and then I'm going to create a public property passengers as integer. Whoops. There we go. And here we're going to set or return m_passengers. m_passengers equals value, right? And then I'm going to paste in some code for my new drive method so I don't have to type the whole thing out. Okay, so I've pasted in my new drive method that will what's called override the previous version of the drive method in the car class. So this is specialized. Notice that I've done a couple of things here, like I have now called utility.calculate gas prices, and I've also changed up the result string just to make sure that you understand that we have specialized the drive method for the minivan. Now I get a little bit of a green squiggly here, says that drive shadows an overridable or overloadable member declared in the base class car. If you want to overload the base method, this method must be declared overload. So here's one thing that we need to do is add one more keyword in order to make this work, in order to tell Visual Basic that we intend for this method to be used instead of the car's version of the drive method. And the way we do that is through the overloads keyword. So public overloads function drive, passing in the miles as string and so on. Okay. So now I'm going to go back to my form 1 and I'm just going to paste some code here to populate all of our public properties that are defined in the car class plus our public property that's defined in the minivan class. And I'm going to call the new drive method that overloads the existing drive method in the car class. Let's go ahead and run this. See if it works. Here, I'm just going to ignore that. Call the constructor, and you can see we have a new message box that is distinct and specialized to our minivan class. The Town & Country now has 2,575 miles, mostly to soccer games, costing $26.25. Okay, so there we go. Okay, so there's a lot more to inheritance, and we've really only scratched the surface, but you can see how the basics of inheritance works from the little simple example that we just went through a moment ago. We're coming to the close of this video, and I decided to wait until now to point out some of the benefits of object-oriented programming. And as I said earlier, these may not be very obvious at first. After all, it seems like these things will actually make your life and your code a little more complicated. But as you begin to develop applications, you're going to begin to see where approaching application development using object-oriented principles can actually make things a lot easier. First of all, the benefit begins when designing your application. Object-oriented programming starts with analysis and design. It provides a logical way of breaking down a big problem into small, easy-to-digest, bite-sized pieces. It's easy to think of the major classes your application might need and then start adding properties and methods to each of those classes and then chart the interaction between the classes and so on. It's just easy for you to think in those terms whenever you get started going down that path. And there's actually a whole set of methodologies created by various people to help you through this process. Now, that's a little bit outside the scope of this series of lessons, and quite frankly, it's a little bit too early for you to worry about that stuff. Just thinking in terms of objects sometimes makes conceptualizing this big problem about how to construct a program a little bit easier. Secondly, if you keep everything related to a car in this instance in one class, it makes it easy to change how your application functions by just changing the code in one spot. Now let's assume that you wrote your application in a very haphazard way. You got a lot of places in the application where you're allowing the user to modify the car data. Now, what if your boss comes to you and says that you need to change the way the application modifies the car data? Now you've got the unenviable task of searching through all the code that you've written, through dozens of forms and dozens of files, to find where the car code can be, the car data can be modified in code. And then once you find that, you got to carefully change it and hope that you didn't miss anything or forget something, because if you miss something that needs to be changed, you've really got problems. Now, how are you going to find it? Okay? At the very least, you would have created a lot of extra work for yourself, and your application becomes a lot larger than necessary, and you make it more difficult to update in the future. But by taking a more object-oriented approach, you would just change the method in the car class that modifies the data, and you're finished. If you introduced a bug, all you have to do is isolate it to a single spot in code. And that actually brings us to a third benefit. By encapsulating functionality in your class, the code that creates and uses an instance of your class might not have to be changed, even though you update how your class operates internally. This goes back to that concept of black box programming. The user of the class doesn't really have to be concerned about how things work internally. All it has to know is that here are the parameters that the class needs or the method needs in order to get the job done, and how it works behind the scenes isn't really important as long as it works. So that really makes for more easily updated applications that hopefully have fewer bugs. And then there's also the potential benefit of reusability. Now, since your car class is modular, all the code related to a car is basically in a single class, you could copy that class file and use it in different projects. You wouldn't need to rewrite any of the code in order to gain all the benefit of your car class. You've already worked out all the bugs, so that saves you a ton of time whenever you're designing, developing, and debugging new code. And those are just some of the more obvious benefits of object-oriented programming. There's a lot more that I could talk about, but I suspect at this point that your head is probably spinning. So we're going to stop for now. But let me do this. Let me encourage you to do two things. First of all, watch this video again, or actually these two videos again, and follow along with the examples. Pause the video when you need to try something yourself. Really take the time to work through some of these ideas. I also recommend that you take a look at the additional readings that I put together in the accompanying document for this series of lessons. Also, search online for more information about some of this stuff. The quicker you get this all under your belt, the quicker you're going to be on your way to developing more robust applications. So I encourage you to not make it harder than it really is. This is actually pretty simple stuff once you get your hands around it. And don't feel like you have to understand all this 100% before you can be productive. That's simply not true. Like I said at the outset, it might take months or years before you master some of these concepts, before you see the value in using this approach towards building your applications. This is really just the first step in a journey, so by all means, don't get discouraged. Just keep plugging away. Before you know it, you're going to know everything that you need to know in order to build applications that are object-oriented. Okay, if you enjoyed this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one, aimed at all skill levels on many different topics related to C#, Visual Basic, ASP.NET, and more. Thank you.